Hello everyone, I'm Varsha studying Computer Science and Engineering in Sri Venkateswara College of Engineering. Today's video is about corrosion, types of corrosion, corrosion control methods, galvanization, cathodic protection, sacrificial anode method, impressed current method. Corrosion. Corrosion can be defined as the destruction or loss of metals or alloys by the surrounding environment through chemical or electrochemical reactions. Example, rusting of iron, tarnishing of silver, and appearance of green color in copper. Types of corrosion. Chemical corrosion or dry corrosion. It involves direct chemical attack of atmospheric gases like carbon oxide, oxygen, hydrosulfide, sulfuric oxide, halogen, moisture and inorganic acid wafers on metal. Example, tarnishing of silverware in hydrosulfide laden air. Electrochemical corrosion or wet corrosion. It occurs due to setting up of large number of tiny galvanic cells in metal in presence of an impurity as well as in presence of moisture. Generally, impurity, more active metal, acts as anode and original metal acts as cathode. So, anode is a area where corrosion occurs. Example, rusting of iron in moisture atmosphere. Corrosion control methods. Corrosion can be controlled by preventing formation of galvanic cells on metal surface. Methods to control corrosion are galvanization, cathodic protection, sacrificial anode method, impressed current method. Galvanization, the process of coating zinc on base metals like iron and steel surfaces by hot dipping is known as galvanization. Steps involved in process of galvanization. The metal surface is washed with organic solvents like CCl4, toluene, benzene to remove organic matters. The metal surface is treated with dilute sulfuric acid to remove rust and other deposits. Then the metal is washed with water and it is dried by passing with hot air. The metal is treated with mixture of zinc chloride and ammonium chloride which prevents the oxidation of coated metal. Then the metal is dipped in molten zinc at 450 degrees Celsius. Excess of zinc on the surface is removed by passing a pair of hot rollers which removes the excess of zinc and produce a thin coating. Application of galvanization. Galvanized steel frames are used to build houses. Car parts are made up of galvanized steel. For example, body parts of trucks and buses. Galvanized metals have found its way in several household applications such as washing machines, air conditioning, housing, hair dryers, computer parts, etc. Nails and buckets are made up of using this type of galvanized steels. Many commercial buildings have exterior layers of galvanized steel, mostly on walls and pillars, to protect the entire structure from rusting and corrosion. Cathodic protection. Cathodic protection is a technique of offering protection to the specimen against corrosion by providing electrons from an external source. There are two important methods of cathodic protection: sacrificial anode method, impressed current method, or voltage method. Sacrificial anode method. Metal to be protected is connected to more anodic metal using metallic wire. More active metal gets corroded while parent structure is protected from corrosion. The more active metal is employed and is called as sacrificial anode. Sacrificial anodes are to be replaced by fresh ones as when it is required. Commonly used sacrificial anodes are magnesium, zinc, aluminium, etc. Example, steel pipe is protected by connecting it to a block of zinc. In such cases, steel acts as cathode and it is unaffected or protected from corrosion, and zinc acts as anode and undergoes sacrificial corrosion. Applications of sacrificial anode method. Sacrificial anodes are used to protect the hulls of ships, water heaters, pipelines, distribution systems, and above ground tanks, underground tanks, and refineries. Anodic protection have also been used in plants to manufacture, storage, and transport the sulfuric acid. It reduces the iron dissolution in sulfuric acid to 1 ppm per day of storage. Advantage of sacrificial anode systems over Others are they no need external power source, are easy to install, low voltage and current between anode and the surface is protecting infrequently and generates stray current and overprotection is unlikely and inspection and monitoring is simple. Impressed current method. In impressed current method, electrons are supplied from the source of direct current, that is battery. In impressed current method, the metals to be protected is connected to negative terminal of the external DC supply. The positive terminal is connected to inert electrode such as graphite. Under this condition, metal acts as cathode and hence it does not undergo corrosion. Inert electrodes acts as anode but it does not undergo corrosion because it is inert. Applications of impressed current methods. Applications of this method are seen in case of water tanks, buried pipelines carrying water or oil condenser and transmission lines and ships. Impressed current cathodic protection system are typically installed to prevent corrosion of metal underground storage tanks and associated metal piping system, and it requires a low installation cost and minimum maintenance cost after installation. Corrosion penetration rate. The corrosion penetration rate is defined as the speed at which any metal in specific environment deteriorates due to chemical reaction when it is exposed to corrosive environment. The amount of corrosion loss per unit time in thickness or the speed at which corrosion spreads to inner portion of the metal. Corrosion depends on the metal and the environmental condition. The CPR is given by CPR is equal to Kw by D into A into T, where K is a constant, W is total weight lost, T is the time taken for loss of metal, A is the surface of the exposed metal, D is the density in gram per centimeter cube. Corrosion penetration rate is expressed in terms of thickness or weight loss when metal surface corrodes uniformly across an area. This method involves exposure of weighted piece or test metal or alloy to specific environment for a specific time. This is followed by thorough cleaning to remove the corrosion products, then determining the weight of the metal after corrosion. The rate may vary if the rate is expressed by the formula above is compared to corrosion rates for the period longer than an year. The rates calculated over short periods. This is because the short periods are prone to fluctuating environmental changes from season to season and from day to day. Thanks for watching the video.